September 23, 1999. A spacecraft reaches Mars after 9 months in deep space. It is supposed to disappear behind the planet, fire its engine, and come out the other side in orbit. Instead, the signal drops 49 seconds early, and it never comes back. Welcome to the final save. This is the story of the Mars Climate Orbiter, a mission built to study the weather of another world, and lost because 2 parts of its own ground system did not agree on what a number meant. The strange thing about this failure is how small it sounds when you say it out loud. Metric units, English units, newtons, pounds. A conversion that should have been routine. But spaceflight is not destroyed only by spectacular explosions. Sometimes it is destroyed by an interface, a file, a field in a system that one team writes one way and another team reads another way. Mars Climate Orbiter was part of the Mars Surveyor program, NASA's attempt to send smaller, cheaper planetary missions more often. The idea was not foolish. The agency had already learned how expensive a single flagship failure could be. Smaller missions promised more chances, faster lessons, and a steadier rhythm of exploration. The orbiter had a practical job. It would study the Martian atmosphere from orbit, temperature, dust, water vapor, the daily weather of a cold desert planet. It would also serve as a communications relay for Mars Polar Lander, another spacecraft following behind it. On December 11, 1998, Mars Climate Orbiter launched from Cape Canaveral on a Delta II rocket. It began a 9-month trip across roughly hundreds of millions of kilometers toward Mars. For most viewers on Earth, that cruise looked quiet. The spacecraft was a point of radio light. The work happened in navigation rooms, in trajectory models, in tiny engine firings meant to correct the path before arrival. Those corrections mattered because Mars' arrival is unforgiving. The spacecraft was not going to break into orbit with room to spare. It was planned to pass near Mars, fire its main engine, and then use the upper atmosphere over many weeks to lower and shape its orbit. Too high, and it would miss the aerobraking corridor. Too low, and the atmosphere would stop being a tool and become a wall. During cruise, the navigation team saw something that did not fit. The predicted path and the observed path were not lining up. Small errors kept appearing after thruster firings. The reason was buried in the handoff between systems. One piece of ground software supplied thruster impulse data in pound force seconds. Another system expected that data in Newton seconds. The numbers moved from one place to another, but their meaning changed in transit. The receiving system treated English unit data as if it were metric. That is the kind of bug that feels almost too simple for a planetary mission. But the problem was not just the unit mismatch. The problem was that the mismatch survived. Requirements existed, interfaces existed, and still the wrong number kept feeding the navigation solution. By September 1999, Mars was no longer an abstraction. The spacecraft was arriving. On September 7, it took the only image it would ever return from Mars, a distant view before the critical encounter. On September 15, the team executed Trajectory Correction Maneuver 4. It was meant to refine the approach. In the days that followed, concern grew. Some calculations suggested the spacecraft might pass much lower than intended. There was still a possible correction on the schedule. Trajectory Correction Maneuver 5 could have changed the path. But it was not performed. That is the painful part of the story. Mars Climate Orbiter was not lost because nobody saw anything. It was lost because the warning signs did not turn into action quickly enough. The system had information. It did not convert that information into rescue. On September 23rd, Mars Climate Orbiter began its orbit insertion sequence. The spacecraft turned. Valves opened. The main engine fired. Controllers expected radio contact to end when the spacecraft passed behind Mars. The signal vanished early. 49 seconds early. 49 seconds early. At first, that was not proof of death. Space missions often have minutes of uncertainty built into their most dangerous moments. But the minutes passed. The spacecraft did not reappear. The Deep Space Network listened. Commands were sent. Recovery attempts continued. Nothing answered. NASA declared the mission lost on September 25, 1999. The investigation that followed made the failure famous. The Mars Climate Orbiter Mishap Investigation Board found that English unit data had been used where metric unit data was expected. The trajectory solution was wrong because the data flowing into it was wrong. It is tempting to reduce the entire story to one joke. NASA lost a spacecraft because someone forgot metric. That version is easy to remember. It is also too small. The deeper failure was organizational. A mission built around speed and cost control still needed the slow, boring discipline of interface testing. A contractor output, a NASA input, a software specification, a navigation concern, a skipped correction maneuver. None of those pieces alone is the whole story. Together, they made the loss. Mars Climate Orbiter did not fail at launch. It did not fail because Mars was too far away. It failed because a human-made system could not prove before arrival that every number meant the same thing to every team that touched it. And then the mission after it failed too. Mars Polar Lander disappeared in December 1999. Together, the losses forced NASA to rethink the way it was managing Mars exploration. The agency did not stop going to Mars, but the philosophy around risk, verification, and mission assurance changed. That is the strange legacy of the spacecraft. It returned almost no science. It never became the weather satellite it was built to be. It never relayed Mars Polar Lander. Its most enduring contribution was the lesson written in its absence. In spaceflight, the cheapest check is the one you do before the planet gets close. Every mission has a final signal. For Mars Climate Orbiter, it came 49 seconds early. If there is another failure you think belongs in this series, leave it in the comments. We read all of them.